let's get into the subject matter today, which is the rope model of the multiverse. And before I can get to that, I gotta again compare and contrast the official version of the multiverse against the one from the rope model, because they're different, and I want you to see that difference because that's essentially the main point of the lecture today. So I start with this fellow, and his name is Larry Kraut. I think that's his name. What does Larry say? Well, he says a universe from nothing. What is he referring to? Well, he says he can build matter, something, from nothing. And he's got the process, he's got the mechanism, he's got the causes. And boy, am I interested in this subject. If you can produce something from nothing, especially without God, but I'll even concede God, I'll put God in there, no problem, I'll let you have God. I want God to go to his garage, to his workshop, right? And show me how he builds something from nothing in one frame. Single frame, from one frame to the next. Here we have nothing, and in the next frame suddenly we have something. I want to know the mechanism. And there's no frame in between because we went from nothing to something, and I want to see what the mechanism is. And I'm not sure you can produce a mechanism without a frame in between. So I have a problem with suddenly something popping out of nothing. But that's what his book is about. You see, how is he going to explain this? I mean, obviously he's trying to sell a book. Okay, that's his main point. But how do you do this? This is quite a miracle. And so I was interested in finding out because let me tell you what the issue is. The issue is that we're going to have a multiverse. What separates one universe from another? And you can't say space because space, as far as I'm concerned, doesn't have a fence where space stops and something else continues, as far as I know. I mean, but he who proposes that has to illustrate the fence. Okay, so you got to put a fence there at the end of space and then tell me what continues. What continues? Another space. There's a fence dividing one space from another. So how can you talk about a universe when, as far as I'm concerned, universe is space and matter. That's the universe. Otherwise, you got to define the word universe before you talk about multiverses, multi-universe, multiple universes. Okay, so that's the train of thought here. Okay. And so he said something from nothing. He's going to create a universe from nothing, meaning he's going to create matter and space from nothing. I thought space was nothing, but apparently good old Larry has a different view. And so we have to look at this word nothing. What is nothing? Especially if we're going to be separating one universe from another with this nothingness. What is this nothingness? Okay, and how is it different from space, which I thought was nothing? So yeah, we got to get to the bottom of this word nothing. And so we look it up, and this is what we see. It says nothing, no thing, or no thing. Okay, they have different ways of saying, okay, great. Is the complete absence of anything. The opposite of everything, or its complement. Well, all that they did, and this is out of the Wikipedia, is put an antonym. They say nothing is the opposite of something, and something or anything is the opposite of nothing. And so we have no definition of either one, or we have antonyms. Okay, and antonyms, like synonyms, they're circular definitions. In other words, no definition at all. We have no definition of the word nothing. Early Greek philosophers argued that it was impossible for nothing to exist. Well, there I have to be on their side. Yeah, nothing cannot exist because only objects can be said to exist. You cannot say that space exists, or that nothing exists, or that vacuum exists, because what do you mean by exist then? And yeah, the atomists, by the way, Democritus and Leucippus, right? The atomists allowed nothing but only in the spaces between the invisibly small atoms. For them, all space was filled with atoms. And again, you're talking about space being filled. And again, this is where the notion of space as a container arises. They treat space as, oh, we're filling space, like you fill an ocean with fish. And they're displacing this container or this medium called space. No such monster. You don't fill space. You do not displace space. Space has no surface, so it's not like you're pushing space all the way to the edge of space where another medium continues. So yeah, this notion of filling space, that's what's irrational. You got to define space before you can say that, and space is nothing, and nothing, what is nothing? Well, obviously if they say it's the opposite of something or anything or a thing, well then we got a problem, okay? because then nothing is the opposite of something. And what is something? Well, it's no nothing. That's what something is. No nothing. We have just negatives. Okay, Aristotle took the view that there exists matter and there exists space. Again, there exists space. No, space cannot be said to exist. A receptacle, in other words, what? A container of some kind, into which matter objects can be, or material objects can be placed. Okay? Yeah, again, space is not a container and space exists. Are you kidding me? And that's because they didn't define these words. That's the issue. It is word salad what they're doing, not what I'm doing. I'm trying to define these terms so we can talk rationally. They never defined that they're doing word salad, or failing to do so, meaning they're failing to define words. And here you have, this became the paradigm for classical scientists when, in the days of Newton, from then on, scientific revolution of the 17th century, Descartes argued against the existence of empty space until the scientific discovery of a what? A physical vacuum. Talk about an oxymoron. All they said, a physical something, vacuum, nothing. So we have a something, nothing. That's what a physical vacuum is. So yeah, these people just put words in there, what we call word salad, okay? That is a play of words. And why? Because they never defined any of them. That's why they can get away with this nonsense. Okay, and what is space? I mean, that was nothing, and space is not nothing, so what is space if it's not nothing? Well, let's find out. Space, in which three values, coordinates, are required to determine the position of a point. That's a space. What's that got to do with physics? All they're saying is, look, we have three, what? Not coordinates, called number lines. They have all these three number lines, and they determine a point, which is what? A position or a point, which is a number. That's what they're talking about. They're saying, look, it's a pair, ordered pair, or an ordered triplet, or a quadruplet, or whatever. And what they're talking about is how to locate something with coordinates, really meaning by number lines. And more commonly, it is defined as three-dimensional Euclidean space, n space, etc. Dimension n equals 3 that models physical space. Again, the something nothing. A space is a set. Set? What is a set? Sometimes called a universe. So now they have a universe. Okay, we have the set, the space, the universe. They bunch it all together with some added structure. What structure? There's no structure in math. Well, modern mathematics uses many types of spaces, such as Euclidean spaces, linear spaces, topological spaces, Hilbert spaces, probability spaces. They have all these spaces. It does not define the notion of space itself. So they have no definition of the word space, but they use the word space. They say, oh yeah, we locate points within space with three number lines. What do you mean by space? Oh, we don't know. We just locate points in space. That's what we say. So they treat it as a container, as a physical object, and they're only talking about math, how to locate a point using number lines, three number lines in this case. Sometimes they use two number lines for the typical Cartesian coordinates. Okay, a space consists of selected what? Mathematical objects. What the hell is a mathematical object? What is it, number 5? Is that a mathematical object? An equation, is that a mathematical object? That are treated as points. Yeah, numbers, that's what they're talking about. And selected relationships between these points, these numbers, that's what they're talking about. The nature of the points can vary widely. For example, what are they? The points can be elements of a set, meaning numbers, functions of another space, meaning an equation, or subspaces of another space, meaning numbers of numbers. Subsets of numbers. It is the relationship that defines the nature of space. Yeah, and so we have a problem here because these people don't define their terms. They use the word liberally. They use words of ordinary speech. They say, well, you know what I mean. I'm talking about space. Oh, yeah, okay, I know what you mean. And what they're talking about is two coordinates, meaning two number lines or three number lines or four number lines necessary to locate a point where within space, which is a container, which they can't define, which they don't know what it is. They never defined it, but they said, we're going to use the word because we like the word. And somehow that crosses the boundary into physics, and now they're talking, they started with math, they end up talking about physics, say, oh, we can tell you what the universe is like because the physical world is represented in the language of math. That's the whole story. That closes the circle. Okay, so what's the problem with Larry? Well, here, let some other people talk for me. Okay, here's one fellow, and his name is David Albert. He's a physicist, mathematical physicist who went into philosophy, really. And he says the following. He criticizes what Krauss says about nothing. He said, the main theme of the book is the claim that we have discovered that all signs suggest a universe that could and plausibly did arise from a deeper nothing. involving the absence of space itself. Okay, so space is not nothing. Space is different. So space came into being from nothing. Okay, yeah. I understand everything. And which may one day return to nothing. We go from space to nothing, okay, via processes that may not only be comprehensible, but also processes that do not require any external control or direction. Physicist David Albert said the book failed to live up to its title, Universe from Nothing. His, Larry's, misuse of the term nothing. Absolutely. If matter comes from relativistic quantum fields, the question becomes, where did those fields come from, which Krauss does not discuss. If you look at his book, okay, at least from the analysis that I've seen, I haven't read the book, I don't care to read it, because obviously it's nonsense, it's poppycock. He's going to equate fields with nothing and say there were fields out there. And from the fields we have space. What is space? A bunch of particles that are made of fields, vibrating fields. What are fields? Nothing. That's more or less his train of thought. And so you say, well, hold it, what are these fields? Where did they come from? That's nothing. So I don't have to justify it. That is the nothing. That's more or less his argument. And here the New York Times also did an analysis, and it puts it clearly where I just mentioned. Certain arrangements of the fields, for instance, correspond to there being 14 particles in the universe. This is out of his book, Larry Krauss' book. And certain other arrangements corresponding to there being 276 particles, and certain other arrangements correspond to there being an infinite number of particles. Okay, so we have countless particles, great. And certain other arrangements correspond to there being no particles at all. Okay, no particles at all. Okay, so what do we have if we have no particles? And those last arrangements, the one no particles at all, are referred to in the jargon of quantum field theories. So he's saying, look, there are no particles, what you have is fields. Okay, what are these fields? For obvious reason, as vacuum states. So he's saying a vacuum state consists of fields. Fields are not particles, even though you have Sean Carroll saying that particles are the vibration of fields, local vibration of fields, right? Because he's trying to explain how space-time is related to quantum, right? And so here we continue. It says, Krauss seems to be thinking that these vacuum states must amount to the relativistic quantum field theoretical version of there not being any physical stuff at all. So he's saying these fields are nothing. So he doesn't have to justify it because he's reached the end of the line. He says, I'm there already. I've proven that space and matter came out of nothing. What is nothing? A bunch of fields. What are fields? Nothing. And that's why I don't have to justify it. I already proved my point. You missed it. And he has an argument, or thinks he does, that the laws of relativistic quantum field theories entail that vacuum states are unstable. Okay, so who cares? And that, in a nutshell, is the account he proposes for why there should be something rather than nothing. So he doesn't start from nothing. He starts from fields and equates those fields with nothing. And he says these vacuum states are unstable, meaning they're already in motion because they're unstable. And so what is it that is in motion? And he says it's nothing because fields are nothing. Even though you have Sean Carroll saying, well, fields are something, the vibrations of fields are what particles are, which is what fills space, and we call them virtual particles because they can come in anytime they want at the request of a mathematician, ad hoc, just pull it in whenever you need it, briefly so that you can't measure it or detect it, and then it goes back to being space again. And so what are these fields? Well, fields are space. So are they something or nothing? Do they have shape or not? Or what are we talking about? Are they just vectors? Well, what are we talking about? And so, yeah, they never illustrate their theories because they can't. That's the issue. Just like the etherists, they can't illustrate their theory. Because as soon as they illustrate it, you pin them against the chords and start pounding them. Okay, so here's another fellow. His name is Neil Tyson, and he does most of the same thing. He proposes the same thing as well as Max Tegmark and some of these other fellows. Brian Greene and so on. Our minds cannot fathom the idea of a multiverse. Yeah, you cannot because you have no way of separating one clump of matter, as I call it, from another if they all share the same space. And what is universe? Space and matter. And so unless you can put a fence between one universe and another, you cannot talk about multiverse, many universes. Quantum fluctuations would be responsible for another universe having slightly different laws of physics than ours. Yeah, great. You got to separate and not tell me about laws. You got to tell me physically what separates one universe from another. Not tell me that they have different laws of physics. Okay, you haven't justified that. You're just talking out of your ears, nose holes. New universes are created, forming an endless number of worlds. Yeah, that's a great statement. You got to tell us what separates from one universe from another. And we have to distinguish a little bit here between the multiverse to some degree and the many worlds version of quantum mechanics, which is for every step you take, you branch off into a different universe. And that's only a way of eluding the question. People say, well, why did this happen? And they say, well, in this universe. But in another universe, something else happened. Here you won the lottery. Over there, you lost the lottery. So they don't have to explain anything. They just have to say you just branch out in different universes. Why? Because they're talking about statistics. They're saying statistically all these things could have happened. And they all did happen because quantum allows for all of them to happen. And if they all did happen, they can't happen in the same universe. They have to happen in separate universes. And that's a little different than saying physically there are all these clumps of matter. We'll call this one universe 1, this one universe 2, this one universe 3, and we have the multiverse. Which means that you have to tell me what separates one universe from another. Where's the fence? What is the fence? Tell me what separates one universe from another. And if we all share the same space, it's just one universe because universe is matter and space. Okay? And that's where you got to begin, definitions. And again, here we have this fellow, Robert Laughlin again, just for reminding you again that they talk about the ether. So what is space? Space is ether, bunch of particles. That's what it's always been. Nothing's ever changed. So if space is a bunch of particles, which is what he's saying there, or space contains countless particles, it's all filled with space with particles, and these particles, the virtual ones at least, can pop into the real world, whatever that means, from the non-real world, and for a brief period of time so that they affect something that you can't measure and then go back. Well, that's great. It's something you can't prove, you can't measure, and they just say it is so because we have no other way of explaining our equations. Okay, I see how it is. You just do ad hoc things. You put them in by hand. Okay, great. Okay, so that's what space is. It's full of particles, okay? So I don't care if it's full of particles. You got to tell me what separates one universe from another if you're going to talk about the multiverse, okay? And so once again, I show you the difference between the ether world of quantum mechanics, which is the same one they've always had, bunch of particles and a single thread, because I'm going to contrast my multiverse from theirs. And I'm going to say that a single thread comprises all the matter in one universe. Why is it one universe? It's one universe because all the matter made by that thread, weaved by that thread, every atom and every rope that connects every atom is made of a single thread. And it's a closed loop thread. So anything that is not attached to it comprises, you can say, a different universe. The problem here is that you have to separate one universe from another, and you can't because you got to put a fence around space. Then you can separate one universe from another. And so what you have to do is put either the fence or say there's only one universe. So what is that single thread? Well, it forms a clump of matter. That's the best word I can come up with. You can call them an island, whatever you want to call it. You can call it island or clump. And we have one thread that makes up all the matter in our universe, but it's not connected. None of those atoms are connected to the atoms of another universe. That's the idea, okay? So what we have is something that, but we've got to begin with a definition. So let's begin there first so that we have it in the right context, okay? This is the definition of something, that which has shape. What is an object, thing, entity, substance? Those are synonyms of the word something. What is nothing? That which doesn't have shape. Synonyms, there you have them: space, vacuum, void, nothingness. What is universe? Something and nothing. So it includes the nothing. Universe includes space. Universe includes nothing, includes vacuum. You can't get away from that because otherwise you either have matter or you have nothing. You have space. If you want to talk about universe, you got to put them both together. That's what the word universe means. Okay, we got the definitions. Okay, you got some other definitions, no problem. You got to defend them. You got to bring them up, say this is what universe is, this is what nothing is, this is what something is, no problem. You got to put them out there and defend them against attack. And I have no problem attacking you. Believe me, I love it. Just like I attack the ethers, the flat earthers, electric universers, and the mainstream, I'll attack you too. Okay, if you don't follow those definitions, I need to know why. You need to defend those definitions. You can't say, well, it is so because I like it, and my brother likes it as well. Just the fact that your brother voted for your definition doesn't make it so. You got to defend it. Okay, so here's our version of the multiverse. Okay, we have all these threads, and of course, each one of those forms all the matter comprised by one of those threads. Okay, so each one is separated from the others. That's the only thing I want to show here. Okay, so you have each one of these threads. They have, in our universe, you can say the one on the upper left there, that's our universe, and it's a certain size, I guess you could say. It has a certain amount of thread. Maybe the laws of physics, as they say, are different. In other words, maybe the speed of light is different from the other universes. Maybe the atoms are different sizes, different masses, etc. That could be if we're made of different amounts of thread. But this would be the notion of the multi-universe in the rope version. But what we're talking about is not multi-universe. You're talking about a single universe. What you're talking, because they all share the same space, because you can't put a fence around space. The thread there that you see is not a fence. I'm just putting it there so that you can see this. And here, let me show you. You would have all these clumps of matter. And again, you got to forget about the thread. Okay, the only reason I put the thread is you can see it better. But what you're saying is, look, all these atoms in one universe are all connected to each other, and they're all made of a single closed loop thread, which is not connected to any of the others. The universe is one. The clumps of matter, island, whatever you want to call those are, you could say, multi-universe, multi-clumps, multi-islands. And within each one, you have galaxies. Within each one, you have stars and so on. That's the notion that we have for the rope version, rope model of the multiverse. Okay, and so this takes us to our conclusions. First, let me show you what the conclusions are for the establishment. They never define the word universe. That's a big problem. They never define the word space or matter, for that matter. They have no idea what any of these words mean. They just use them. Ordinary speech, they say, you want to know what they are, look in the dictionary, or go ask, what is a philosopher, physics, or a English major, librarian, any of those. They treat the universe as a thing. They treat space as a thing. They treat them as both, as a nothing and as a thing. They treat it as both something and nothing. And that's why they get away with murder. Okay. Universe out of nothing, according to Larry. Yeah, we got a problem there, because he says it comes out of fields, not of nothing. And of course, he's going to elude the word field. And that destroys his entire book, which is out there only to make money. That's it, because of his name. Because he's more or less a celebrity in the world of mathematical physics. Physics being too big for him. Expanding universe, what is that? What is expanding? It's space. It's this dark energy that's blowing everything apart. What is that dark energy? What is that space? Well, it's something. What's it pushing against? It's an unscientific question, because we don't know, where the universe ends. It's like asking what's north of the North Pole. What are you talking about here? You're talking about what's outside of space, and why is it an irrational question according to them? It's because we have no way of proving it. So it's not really so much of an irrational question. It's an unscientific question, a philosophical question, because we have no way of verifying what's outside of space. No, it's very simple. Draw space, and we'll know what's outside when you identify it in your picture. Then we'll know what's outside of space. You have to tell the crowd, not say, hey, guess what's outside of space? And yeah, we can't prove it because we can't go outside of space. Not even God can step outside of space, because he's got no boundary to cross. So to say outside of space is irrational, because space is that which has no shape. It has no boundary for even God to cross. Poor fellow's looking for the end of space. He's still trapped in here with all of us. So what does multi-universe mean? Well, it really means, under the rope model, right? It means islands, clumps of matter, but we all share the same space. But under the mainstream version, until they define space, until they define the word universe, we'll never have a clue what they're talking about when they say multiverse. They talk about the different laws of physics. They don't talk about physical separation, which is what we need if we're going to talk about multi-universes. And how does it relate to the fourth dimension? Only God knows. Okay, and God's in the fifth dimension. Okay, and so here's the conclusion for the counterpart, the rope model. Okay, here you have it. We have the single thread model of the universe. That's the whole universe as far as we're concerned. But there's nothing wrong, nothing preventing us from having multi-threads. Okay, each one of those comprises an island, a clump of matter. Okay. The thread is an object, so we're talking about something physical. Now we're not talking about mathematical concepts such as field and energy and any of that. we could have many single threads out there. They're unconnected. That's why remember, they're closed loop threads. They're unconnected to each other. So none of those atoms from that universe are connected to any of the atoms in our universe. So we have each one is made of its own single thread. Okay, and they could have different speeds of light, different masses for the atoms, all that kind of stuff. What does exist? Well, it's object plus location. So we have an object. It's called a single thread. Does it have location? Well, the only way it can have location is if there are other clumps or single threads out there. Okay. And yeah, we can say that, we can speculate and say, yeah, if there are other clumps of matter out there, our universe can be said to exist, following the definition, right, strictly, because, one universe has location with respect to another universe, and these universes all are disconnected from each other, okay, so no problem there. And so we can use the word exist in that context. Otherwise, it's irrelevant. We're talking about existence of matter within our universe. And for that, all you have to have one object, any atom, or anything made out of atoms, having location with respect to another group of atoms. That's it. We won't figure it out, through any test or experiment. This is just an entertaining issue to ponder, a philosophical issue. Could there be other universes out there? Well, it's something to kick around at the water cooler. Nothing more than that. We'll never figure it out. This is just speculation, and it's nice to talk about it. No more than that. It's not like we said, oh, I'm going to prove to you that there are other universes. No such monster. And in that sense, it doesn't mean it's unscientific. It just means it's nice to talk about it. Nothing more than that.